Yeah, well, if I get it on there. So specifically, right triangles with this section, going back to the basics, cosines, sines, and tangents. That does not mean you cannot use the reciprocal function, because you can. Remember that a cosecant is, instead of an O over an H, it's an H over an O. So we can still use those. In fact, the first couple problems in the homework, I think, ask you to write two functions, reciprocals of one another, which means if you use a sine function, then you're also going to use a cosecant function. Now, in terms of setups for triangles, generically speaking, we use lowercase letters to represent the length of sides. And then you'll either use Greek symbols, Greek letters to represent the angles, or you might use capital letters. So the angles and their respective sides that they are across from always have the same letter. So little side A means angle A would be right there. And then little side B means angle B would be right here, and there's angle C. So you could see it labeled with either of those formats. So don't get too hung up on the triangle, because there will be some problems where it says you have angle A, which is 40 degrees, you have side B, which is 6, side C, which is 12. And from that, with no picture, you should be able to create the triangle. And it really doesn't matter where A and B are. It doesn't matter really where any of them are. So just pay attention to where that right angle is. And they might even use different Greek letters besides alpha and theta. They might use alpha and theta. All right, so let's get down to business here. Finding the values of x. You're going to see this, you're going to, oh, I remember this. This is like geometry stuff, and that's exactly what it is.
I know.
Oh, was it? Yeah? Plenty of this on there?
Is it 3? Hold on. 3 sine 60? Or is it sine 3 over 60?
Well, you almost had it. It's the sine of the angle is equal to 3 over x. Opposite. So remember, the angle, side across from the angle is the opposite. So yeah. Now, depending on the angle you may have one of the two acute angles, but wherever you are with the angle and the sides that are around it, remember that when you have an angle, if the side right next to it is given, so let's say you had, for example, this side right here, whatever it was, that would be an adjacent. And then the angle of 90 degrees, always across from the angle of 90 degrees is the hypotenuse. And then across from the angle that you've been given is always your opposite. So this sets up as a sine, but it could also set up as a cosecant. Okay. This could be a sine or a cosecant. So a sine of 60, opposite, hypotenuse, which means we're setting up 3 over x, or a cosecant of a 60 is equal to an h over an o, x over 3. Now the only deal with the reciprocal functions is, again, we don't have those functions within the calculus. So that's why we just usually always defer to sine, cosine, and tangent. So, okay, watch this. It's going to freak people out for whatever reason. X is equal to 3 over the sine of 60. How did that happen? I just set up, you can look at it like a proportion. Sine of 60 over 1 is equal to 3 over x. Cross multiply. 3 equals x sine 60 divided by sine 60. Right? And you get that. Well, what is 3 over the sine of 60? We can do it as a non-calculator problem. What's the sine of 60 in terms of our reference triangles? Root 3 over 2. Yeah, 60 is a root 3 over over 2, which means this could be written as a 3 times a 2 over root 3, which is a 6 root 3 over a 3, which is a 2 root 3. Just rationalizing this phenomenon. For the sake of change, flip it. Got it. Or make it a decimal, and this is approximately 3.46, I think. If you can leave your exact answer on there, that's better. Depending on the problem. Like if it's an application problem. Let's see. Okay. All right. Well. So there we go. Setting it up, we get 3.46. And it should be longer. It's the longest side, so it should be longer than the leg, and it is. Leg was 3. One of the legs was 2. All right, let's go to the B, and then we'll roll into some questions you guys might have. Do I need trig to solve B? Why not? Well, if I'm going to use Pythagorean theorem, I need to know something about this. So you see that there's 2 right triangles here. I would need to know that. How do we know? There we go. There's the word. It's isosceles. The big triangle is isosceles, right? This triangle here is isosceles, which means those angles have to be the same. And then you have a situation where you have a reflexive side x. You guys remember all this stuff? You don't remember that from geometry? Like in 8th grade. Yeah, just for pickle.
Because she also talks about 2 sides are equal to the 15th, the hypotenuse is equal, and then the sides are touching each other, you know, are equal.
Yeah.
And then you have the right angle, which has to be equal. So it's not the rules like
Yeah.
side.
Yeah, side angle, side, congruent.
Yeah.
No.
I just feel like we have to do that on the sign this question.
Okay, so we know this length is 13 to here. It's the same thing there. So if I'm looking for an angle, then yeah, I'm going to need to do some trig. But I'm not looking for an angle. I'm looking for the length of that vertical. So you can have this like a construction. This is what they would do in construction. They're building a gable roof or building a truss, and they're trying to figure out what does that height need to be given the certain pitch of the roof. It's all good stuff, isn't it? Pitch, truss, right? So I can set up, if I look at this as my right triangle, then I have a situation where I've got all of the parts to just be able to use Pythagorean theorem. 15 squared minus 13 squared, take the square root of that, and that's what x is. So I didn't really need trig for this. 2 root 14. And if there were units associated with feet, inches, make sure you include them. But this is unitless. Okay, so pretty basic, right? Straightforward, just right triangle trig. Why are we doing this now? We're doing this now because we're going to go into situations where I have no right triangles. And how does that relate to what we're doing here? Well, we'll talk about 2 laws. One of them called the law of cosines, one of them called the law of sines. And that's how we'll be able to take care of triangles that don't fit right triangle description. All right. How about that one? Once you knock that one out. Now, if I ask you to solve for a triangle, I'm asking you for all of the missing pieces, which include angles and sides. So here we're missing a side C, one of the legs, and then angles B and angle C. So why don't you go and find those things for me? Okay, now that's a good question, or a good comment. Tangent 90, what do we know the tangent of 90 would be? Undefined. Tangent of 90. So let's not ever use our 90-degree angles. Let's always use our acute angles. You don't know them, great. So what do we have to do to find missing angles if I don't? How are we going to do that? let's say we're going to look for angle C. What? So if I wanted to find angle C, which trig functions do I have to use? Cosine. Yep. I have an adjacent side. I have a hypotenuse to that angle C. So if we're just setting up generically, we say cosine of angle C is equal to adjacent over hypotenuse. Well, we're looking for the angle, so that means we have to use a what? Inverse. Very good. So we're having to find an inverse, which means we're doing this. And then I'll make sure that I'm in degree mode because angle A was given in degree. And then I find my answer, which I think, if I remember correctly, 43.6. Now, do I need to use trig to find the other acute angle? No. Because I know that two acute angles of a right triangle always add 90. So that means I can say that angle B is just simply 90 minus angle C. So we have 90 minus 43.6, and I get 46.4 degrees is angle B. Cool. How would we find C? I could use diagram. Yep. What else could I do? I could do sine. I could do cosine. I could do tangents. Right? If I did cosine, I'd be using angle B. If I did sine, I'd use angle C. Either B or C, I could use tangent with. So either of those, or just use diagram. We can find C. 29 squared minus 21 squared, square root of that whole thing. I think this is 20. All right? All right. So we found all of the parts there, sometimes using trig, sometimes just using diagram. Fabulous. That's kind of a little breath of fresh air, isn't it, from the last stuff we were doing? A little bit. Okay, so here I'll let you guys do your, you and your partner here on this one. See if you can figure out based on what we've been given. Oh, and remembering some geometry terminology. Rhombus, what does that mean? Anyway, let's see if we can come up with this. Good idea. Okay, so the big thing here. Congruent sides because rhombus, and if the perimeter equals 40, and we split that into the four sides, we know 10. But you guys already do that. Now here's the other 70 degree in A. Now this is the rhombus angle A. So we're talking about this whole thing. Now if we know anything about some geometry, quadrilateral diagonals, when you have quadrilateral and you have diagonals, they will always do something to each other. Do you guys know what it is? They will bisect each other, right? But they're also going to be splitting the angle that we have here. So this angle A can be split into two 35-degree angles. Now we needed that so that we can look at one of the triangles. So let's just say we're going to concentrate on this triangle right here. Pulling that triangle out so we can find some pieces. We can say, all right, we're going to call that length X, that one length Y. We know that's 10, and we know that that is 35 degrees, and we have a right triangle. So we're able to find both of the components that we're going to need to be able to find the length of our diagonals just from one of these. Right? Did you guys do it this way? You use what? Okay. Yeah, you could use angle B. If you can use this as a 55 degree, that works too. Same thing. All right. So if I go and I set this thing up with my angle, which trig function is going to find X? Cosine. All right, good. So the cosine of 35 equals X over 10. And what did you guys get there? 8.19. So let's just take it to 8.2. Yeah, we do 10 times the cosine of 35. Now that's only half of diagonal AC. So that means diagonal AC is going to be double that, 16.4. And then the other one is going to be sine. And this you got what? What was this say? Say what again?
67.35.
No.
Oh, I almost got that.
5.7? So that means diagonal BD is twice that, or 11.4 centimeters. We in agreement? Yes? All right. So you see how this works now? Pretty much, let's find our right triangles, use the right triangle parts given, come up with our answers. All right, so here's the only thing on this one, is application problem. It's just, again, translating the English part, the descriptive part, into a math language for me. And there's a common mistake that would be made with the reference in here in particular to the angle. Notice that it says 70 degrees with the ground. So this is where a little sketch would be coming in handy. So we got this 20-foot ladder, lean it up against the house, and that ladder has to have a certain angle within a certain angle range limit for it to be considered safe. Unless you want to go for a ride. Then you don't obey those limits. And you have fun on the ladder. Okay, well, that's exciting. So that's what we got. So there's a little schematic, a little drawing, which, as I said, is going to be important. What a lovely house. I just drew that freehand. See, look at this, is a good question. Which part of that
This
little...
one. Yeah.
So you're saying the 20-foot is the hypotenuse? 70-degree angle. That's a big angle. Yeah, so that's probably where we should start. Where does the 70-degree angle go? On the bottom. Now, it's kind of a giveaway because of what word? The ground. But here's another phrase you may see that is not so obvious. You might see something like this. With the same problem, it might say something like 70 degree with the horizontal. All right, now that's not so obvious. Maybe that's obvious. It says some reference of an angle to a horizontal. That means coming off of a horizontal line, turn to the angle. So in that case, 70 degrees with a horizontal would look like horizontal, 70 degrees. So that phrase may be used, I think, probably in some of your application problems, but it's the same thing. So 70 degrees then is this angle here, and yes, that is true that that's your 20 foot. And so we're looking for how far away from the base of the house for part A, and then how high on the house are we able to get the ladder. Now you guys have ever worked the ladder before, especially like a step ladder. These are extension ladders, but a step ladder, you know how it says, like on the third to the last, or third to the top step, it'll say, don't go beyond this point. I never obey that.
Yeah.
So I'm putting out my Christmas lights on my house. I'm standing on the top to get up here, to reach the little lights that are hanging on up here. It's always fun. It's always exciting. And if you ever want a cool little ride, one of my neighbors is doing his Christmas lights, and I kid you not, actually no, he was painting. Second story, painting. Had an extension ladder. And it looked like this. It was the funniest thing in the world. That's what his ladder was doing. So when he was on it, it was going. I was just waiting for it to go right down the face of the house. I mean, it didn't happen. But it was fun watching it. Anyway. All right, find those values for me. How far from the house? How high in the house did we get for our ladder? And then we'll wrap this thing up. If anyone has some numbers, you guys can throw them out. Give me some values. 6.8 for what one? Okay, so we got an x, 6.8. Do I get confirmation on that?
Yeah.
So I'm assuming we set up a cosine for that? You do what?
I did 9 minus 17 and about 20.
So you're working off the top near the house. Okay, same thing. So we get x equals 6.8 t. Okay, and then anyone have a y for me yet?
18.8.
All right, so setting up a sign, we have a y over a 20, and it's 18 point what? 18.8. You guys know that this means symbol-wise, so like that, feet. Okay. All right. So there we go. There's how high we can reach on the house, quote, safely. And, but if you don't want to be, you want to have a little more excitement, then change the diagram to flat. I wouldn't advise that. All right. So, any questions for the beginning of 9 here? Pretty straightforward. Okay. Great.